Hey everyone, and today we're diving into the world of CPUs and GPUs. These two components are like the heart and lungs of your computer, each playing a crucial role in keeping everything running smoothly. But what exactly are they, and what makes them different? Let's break it down. A CPU, or central processing unit, is essentially the brain of your computer. It handles all the general-purpose computations and instructions that make your system tick. From browsing the web to running complex software, the CPU is calling the shots. On the other hand, we have the GPU, or graphics processing unit. As the name suggests, it was initially designed to handle graphics processing, particularly for rendering images, videos, and three-dimensional environments. However, GPUs have evolved into versatile processing units capable of accelerating a wide range of tasks. While both process information, they go about it in different ways, and that's what we'll explore in the next sections. Stay tuned. Imagine your computer as a grand orchestra, and the CPU is the conductor. It doesn't play any instruments itself, but directs all the other components, ensuring they work together harmoniously. The CPU excels at handling a variety of tasks quickly and efficiently, making it ideal for general-purpose computing. Think of browsing the web, writing documents, or running spreadsheets. These tasks involve a lot of instructions being processed sequentially, and that's where the CPU shines. It's designed for high clock speeds and low latency, allowing it to switch between tasks rapidly, giving the illusion of multitasking. However, the CPU's strength in handling a variety of tasks comes at the cost of specialization. It's like a Swiss Army knife, versatile, but not the best tool for every job. And that's where the GPU steps in, especially when it comes to tasks requiring massive parallel processing power. Now, let's talk about the GPU, the muscle behind your computer's graphics and compute-intensive tasks. Unlike the CPU, which is like a conductor managing a small group of skilled musicians, the GPU is like having an army of workers, each capable of performing the same task simultaneously. This parallel processing capability makes GPUs exceptionally efficient at handling tasks that can be broken down into smaller, identical operations. Take gaming, for example. Rendering realistic graphics requires millions of calculations to determine the color and intensity of each pixel on your screen. The GPU's parallel processing prowess allows it to perform these calculations simultaneously, resulting in smooth, high-fidelity visuals. But the GPU's talents extend far beyond gaming. Its ability to crunch vast amounts of data makes it incredibly valuable for applications like machine learning, artificial intelligence, and scientific simulations. These fields rely heavily on complex computations and large data sets, and GPUs have become essential tools for researchers and developers. Choosing your champion CPU or GPU. So when it comes to upgrading your system, how do you decide whether to prioritize a CPU or GPU upgrade? Well, it boils down to your specific needs and how you use your computer. If you're a gamer or work with graphics-intensive applications like video editing or three-dimensional modeling, then a powerful GPU should be at the top of your list. A higher-end GPU will deliver smoother frame rates, faster rendering times, and an overall better visual experience. On the other hand, if your primary focus is general computing tasks like web browsing, word processing, or programming, then investing in a faster CPU with more cores will provide a more noticeable performance boost. This will result in snappier application launches, smoother multitasking, and faster processing times for everyday tasks. Ultimately, the best approach is to find a balance between CPU and GPU performance based on your budget and usage patterns. A dynamic duo: CPUs and GPUs working in harmony. While we've highlighted their differences, it's important to remember that CPUs and GPUs aren't rivals, but complementary components that work in tandem. The CPU handles the general-purpose tasks and delegates the specialized parallel processing tasks to the GPU. Think of it as a well-coordinated dance. The CPU sets the stage, manages the overall flow, and hands off the complex choreography to the GPU, which executes it flawlessly. This synergy ensures that your computer runs smoothly and efficiently, delivering the performance you need for your specific tasks. Understanding the strengths and weaknesses of both CPUs and GPUs empowers you to make informed decisions about your computer hardware. Whether you're a gamer, a creative professional, or an everyday user, choosing the right balance between CPU and GPU performance will unlock the full potential of your system.
Hit that like button, subscribe, and stay informed.